The most expensive factory ever built belongs to the most important tech company you've probably never heard of. TSMC of Taiwan uses cutting-edge lasers to etch intricate details less than 1,000th the size of a red blood cell onto the purest hunks of wafer-thin silicon, while an army of super-strong robots zoom around on tracks traveling the equivalent of 10 times around the Earth every single day. There's every chance you already have at least one of its products, integrated circuits, better known as chips, in your home or car. But what's up with the eerie yellow lighting inside? Why are they such neat freaks? And could the whole vast enterprise soon be rudely swept away on a rising tide of geopolitical insecurity? Join us today as we put on one of those weird suits and step inside the world's largest computer chip factory. If you were asked at a pub quiz to name the world's most important chip maker, you'd probably say Intel, AMD, ARM, or Samsung. Most people have never heard of TSMC, aka the Taiwan Semiconductor Manufacturing Company, and yet it controls more than half the market for made-to-order chips. Sprawled across several clusters of buildings in Taiwan, TSMC's most expensive single factory cost a reported $17 billion, which makes it by some way the most expensive factory ever built. By comparison, Tesla's shiny new Gigafactory in Shanghai cost just a fifth of that. As a company, TSMC decided long ago it was quite happy to shun the limelight. Instead, the firm labors in relative obscurity, making chips on behalf of the likes of Apple, Huawei, and various automobile manufacturers around the globe. This laser focus, excuse the pun, on what TSMC calls foundry services has enabled it to concentrate entirely on breaking new boundaries in the minuscule scale and peerless sophistication of its chips. Here's a quick overview of what they actually do. Intel employee George Moore posited back in 1965 the idea that the number of transistors on any given chip would likely double every 2 years, as the cost of those transistors halved. Moore's law has held up surprisingly well over the following 6 decades, thanks in no small part to the work of TSMC, which is why, in turn, computers have become so much faster and more capable over time. Moore's law means transistors are now, in the second decade of the 21st century, almost impossibly small. The laptop I'm typing this on, for instance, rocks a TSMC-made Apple M1 chip. That chip has over 170 million transistors crammed onto each square millimeter of silicon, with some features just 5 nanometers across. A virus is about 10 times that size. A red blood cell is 1,000 times bigger. 5 nanometers is, get this, fully 100 times shorter than the wavelength of visible light. That's 600,000 times smaller than a strand of human hair. It's really titchy is what we're saying. But that's just the start. TSMC has already inked contracts to supply chips featuring 3 nanometer architecture. TSMC has even, in a highly speculative process involving semi-metal bismuth, trialed 1 nanometer chips. Engineers call these two-dimensional objects because that's basically what they are. But that's all in the future. Let's look at how TSMC make their cutting-edge production chips today. The heart of the action in a TSMC factory, or the fab, short for fabrication plant, is the so-called clean room. TSMC's larger, newer fabs have clean rooms as big as 22 football fields, or 160,000 square meters in size. TSMC clean rooms are, more precisely, level 10 clean rooms, which basically means they're kept in a state where there's fewer than 10 particles of dust per cubic foot of volume. As you can imagine, working on such nanometer scales means even the smallest mote of foreign matter could play havoc with the delicate circuitry. So workers in the fabs, TSMC employs well over 50,000 people, need to thoroughly scrub up before heading to work. That means stashing outside shoes in a locker, tying their hair up in a net, and undergoing a thorough and thoroughly futuristic air shower. Regular air from the outside world passes through many layers of filtration systems to keep out unhelpful particulates. Assorted other environmental disturbances, fluctuations in temperature, swings in humidity, random vibrations, even magnetic fields are tightly controlled for. As luck would have it, TSMC's most important raw material, silicon, happens to be the most abundant element found in the Earth's crust. Quartz sand is refined into molten silicon with 99.9999999% purity. For years, this was delivered to the clean room in cylinders 8 inches in diameter, although refinements to the process and massive hikes in sales now means TSMC starts out with 12-inch hunks of silicon. This means they can fit even more onto the same block of raw material, driving those all-important economies of scale. This cylinder is sliced into thin wafers. At the superfine 3 to 5 nanometer scales TSMC employees work at, precision is a must, as even the slightest mistake would render the cylinder wasted. The silicon wafers are first treated with chemicals including arsenic, phosphorus, and boron to optimize conductivity and other useful properties. These wafers, moved to what's known as the division area, are placed in an oven tube where temperature and gas flows are minutely controlled to create an insulating silicon compound film on the surface of the water. Of course, chips are supposed to conduct as well as insulate, so the next leg of the process, called ion implantation, implants charged ions into specific pre-chosen regions of the silicon wafer. Without getting too technical, the level of conductivity in the final chip is manipulated by finally adjusting the depth of ion penetration at this stage. From there, the wafers are moved to the so-called chemical vapor deposition, or CVD area of the fab, where a solid-state reactant, formed from chemical reactions in the reaction chamber, is deposited onto the chip as a thin, light-sensitive film. This is a crucial detail you need to get your head around. Chip architecture is nowadays so fine that it's carved out not using machine tools, but blasts of light. This special magic takes place in the photolithography area of the fab. Light is shone through a chromium plate etched with the layout of the chip as created by designers at, in the case of the M1 chip, Apple. The light that makes it through etches into the light-sensitive film is what carves out all those minuscule features and pathways. The chip designs themselves are obviously jealously guarded commercial secrets. The dense, complex architecture of each layer, chips typically have between 20 and 30 layers packed together, is transferred from computer-aided design systems onto photomasks, also known as plates or reticles. Once the chip pattern is on the silicon, the wafer moves to the etching area, where fine chemistry is used to strip away any extraneous silicon. It's then polished until it's flat, carefully inspected, then stacked to make the final chip. All these parts are ferried around using robots in the ceiling. 12-inch silicon cylinders are too heavy for people, which collectively travel some 400,000 kilometers every day. It's a busy place. You're probably wondering about that yellow light the clean room is bathed in. Remember we said that light is what TSMC used to carve out the chips? Well, yellow light has a long electromagnetic wavelength, and as such, doesn't interfere with the lithography processes, as shorter wavelengths like blue might. Indeed, one of the biggest challenges for TSMC going forwards into the brave new world of 1 nanometer and beyond is the very wavelength of light itself. Newer processes use so-called EUV, or extreme ultraviolet lithography, for reaching the finer details other chip makers simply can't compete with. Old-school chip maker Intel, for comparison, has been forced to awkwardly dial back its promised 5 and even 7 nanometer chips plans, and is set to outsource 20% of its manufacturing to TSMC over the next few years, an embarrassing climb down for such a global household name. Over the past few months, the central role of TSMC to the global economy has itself been thrown into sharp focus. Taiwan's geopolitical status, in the shadow of the People's Republic of China's claims on the territory, make it look increasingly vulnerable. Already, recent global shortages led to car manufacturers like Toyota, Ford, and Volkswagen halting production because they couldn't get hold of TSMC chips fast enough. TSMC is currently expanding onto the Chinese mainland in an effort to win favor with the People's Republic, as well as opening plants in Europe and the US. The better TSMC can get at making and shipping their wares around the world, the more we'll all come to rely on them when the chips are down. What do you think? Is it dishonest for other companies to market the work of TSMC factories as their own? Let us know in the comments. And don't forget to subscribe for more totally fab tech content.